Hello, welcome everybody. This is week 3 and this is a tutorial for week 3, and here we will be covering the NLP aspect of this course. So here is a brief agenda of this tutorial. We'll be talking about how to read text depending on what are the different sources, and we'll look at some of the basic string manipulation methods, how to change them to meet certain needs that you might have in your work. We'll look at a couple of libraries named NLTK and Spacey. NLTK is a very basic text processing library, and it has a lot of functionality that are quite useful in many of the NLP pipelines. And Spacey is a very production ready, industrial heavy toolkit, and also offers a lot of endpoints which you can very easily use to quickly get some insights. Since we'll be looking at a lot of social media text, I think we should definitely look at some of the pre-processing steps that are necessary to make insights out of social media data. And we'll go through the reasoning of them and certain steps code-wise how we can do some of those things. After that, we'll look at a few feature extraction methods, like how do you convert text into numbers that an algorithm can crunch. Then we'll look at some of the a very simple example of classification methods using the features that we have extracted using these methods. And finally, before ending, we'll look at word vectors like word2vec, fast text, glove, and that family. And we'll also look at some of the very recent, very popular NLP methods known as BERT, Bertology, transformers, etc. So let's get started. I'm sure you are aware of this. We have seen such a pipeline earlier in the course as well. So this is how a basic pipeline looks like. You get some raw text, and this could be taken from, let's say, social networks, or it could be news data or whatever, and then you apply a bunch of pre-processing methods. For example, you have simple normalization where you, let's say, convert uppercase into lowercase. You convert a word to its lemma, to its base form, or you might want to translate it to some other language, something like that. And after that, you might filter out some of the artifacts that you might not need in a particular text. For example, let's say you're dealing with text from one of the social media platforms, and you don't want to keep the hashtags in your hashtags or URLs or any such artifact in your data, because it might not be relevant for your application. Right, so we'll look at so there is basically a filtering step, and then there is a conversion to feature vectors. For example, if you need a ML algorithm or any algorithm to take input from text and make insights out of it, I think it would need to be converted into numerical representations of the text, right? And then the algorithms would run and crunch some insights out of it. So this is the whole pipeline, and we'll look at some of the components, some very basic implementation of some of these components. So moving on, this is how typically a tweet JSON looks like. You might have already seen this in the data collection tutorial, but once you, let's say, query, for example, the one that is being presented on the screen right now is an example tweet, and it's basically it's a bunch of key value pairs, and specifically what we are interested today is this text part of this, right? So when you are querying a API, doesn't matter which social network, usually you get a JSON back, and JSON has many key value pairs, and especially from an NLP perspective, I think we should zero down on the ones that where, let's say, the text of the post is encoded, or text of a comment is present, right? So usually once you get a JSON, you just extract the text out of it, and it's like a simple dictionary read, right? So you extract the text variable out of that JSON. And so for this example tweet that I just showed you, then once we extract the text, this is what it reads, and you can see that there are a bunch of user mentions, and there's a very long text, right? But this is not the only case that you will see. There are other formats in which data might be shared with you. For example, it might be shared as a CSV. Right? CSV is a file where it's comma separated. All the values are separated by comma. For example, let's say if there is a roll number, there is height, and there is weight. So in a single line, there will be roll number of a person followed by height of the person followed by weight of the person, and all of these values will be comma separated. So I think when you are reading such file formats, I think you can use simple read-write functionalities of Python like this, where you just read all the lines and you can split a line at a comma, right? So once you split a line at a comma, you get a output like this, right? So this was the line that you read. This is what the line is. The first line is in the text file, and this is where once you split based on the comma, you will see that there are all these features present in that data set. If you are more interested, for example, if the file that we are reading here, let's say if it runs into GBs, right? Sometimes it's not possible to read the whole file at a time, right? So the code here read lines. Basically, if there are 100 lines in a text file, it reads all the complete file and puts it in the memory, right? So sometimes it's not possible. Let's assume that a file has, let's say, 1,000,000 lines, and you do not have a system that can accommodate 1,000,000 lines in your memory. So what you can do is you can read one line at a time, right? And this is basically the syntax for doing that. So you can iterate line by line, and you can process it however you would want, right? So this is just an example of how you would deal with a very large data set. And this is sometimes the case. In more often than not, this is the case where you end up dealing with not a file with hundreds and thousands of lines, but sometimes it runs into millions and larger than that. Moving on. And again, this is a very simple example of once you read a line, you can again split it based on comma, and you can see that this is basically a columnar data for each column there are values, right? So these are the column names, and this is what you see once you read sample by sample. So far we have covered how to read JSON, how to treat JSON as a dictionary and take necessary fields out of it. We have also seen how to read files like CSVs or even text files where you can read a file line by line. Alternatively, you can also, when you're especially dealing with tabular data, which is nicely formatted in a manner like this, where you have very well defined columns. In such a case, I think one library that is quite useful is pandas. So it's a very simple function here. While we were earlier doing reading all the lines and splitting based on commas, here it's a very simple functionality in the library that you can use called read CSV. So you can read any CSV, and it nicely puts everything in this tabular data, right? So sometimes what we can do is if you're dealing with tabular data, one of the very good libraries that you can use is pandas. Especially in cases where the data that you're reading is nicely formatted into tabular manner, you can use pandas and read this. So this is very comparable to what we saw just a few cells back, where you were seeing that you were reading line by line and then splitting based on commas. While using this simple function, reduces the right amount of code you end up writing, and this is a very simple and efficient way of reading the whole data set in your memory. Again, a callback to what we discussed a while back. Sometimes if the file is too large, sometimes even reading this using pandas might not be a good idea, because it might not fit in your memory. So yeah, so the objects that we create using pandas library are called data frames, and you can see by a syntax like a dataset.head or a data frame.head, you will see the top five rows of the data, and you can quickly eyeball as to what the data is all about. So there are these many columns, and this is what at least some of the samples look like. And by using a function like this, you can print out all the column names and stuff like that. So the crux of what we have discussed so far is that there are many data formats, and you can choose an appropriate library depending on what your need is. So if you're dealing with tabular data, you can use pandas. Sometimes if the data is too large, you can just simply treat it as a text file and read line by line and do necessary processing. Right. Moving forward, we'll look at some of the simple string manipulation methods. The inbuilt functions that are offered in Python for manipulating strings, it's sometimes sometimes just sufficient for many of your needs, right? So let's look at some of them just to introduce basic concept. This is not exhaustive. This is just a demonstrative example. I'm sure there are many other methods that you can explore and use as per you need. For example, we have a simple string like hello s, and the variable name is s, and we have assigned a value called hello, a string value called hello, right? So let's say you want to change it to uppercase. You can simply do that by s.upper. If you want to just capitalize the first character, you can use s.capitalize. If you want to lowercase a letter, it is just a simple function called .lower. And the string manipulation methods, string methods within Python also offer these functions which can give out Boolean values, right? So if you want to check whether a string is uppercased, you can just use this function called isUpper, and it will return either it's a false or a true value, right? Otherwise, if you want to check whether a string starts with a particular value or ends with a particular value, you can use starts with or ends with, right? So you can see the output of isUpper and starts with is a Boolean value, false or true, right? So one of the example cases where you might be interested in this is where you are dealing with file extensions. Let's say that you have a list of file names, and you want to check whether which of those file names end with a particular extension like .json, right? So this is one of the cases where starts with or ends with might be very useful and handy. Some of the other methods like rstrip and lstrip are useful for stripping down some of the characters from your string, right? When you have a line separated data, when you have 100 lines in your text file, sometimes most of the times you will have a line ending with a new line character like /n, right? So but while reading, if you want to remove that /n, right? Let's go back and look at an example. When we read that first line in the CSV, you can see that there is a /n, right? /n, nothing but a new line character, and it once you see that, it enters into a new line. For example, if you're reading this, you might /n is not of a value when you are processing this column, right? So one way to strip away this unwanted characters is usage of methods like rstrip and lstrip, right? So both the methods rstrip and lstrip will take certain arguments like set of characters that it needs to strip away. So rstrip will strip /n, but which are trailing, right? So whatever are there at the end of the string, starting from the end of the string, these characters will be dropped. Lstrip does the other way around. It starts from the front, and it will drop all the characters that it has seen, right? So for example, let's look at example here. In lstrip you can see that we have given that you drop O-N, capital M, small m, and n, right? So any of the characters that is in this set will be dropped, but only at the starting, right? For example, O and N are also occurring at the end, right? But they are not dropped, right? What occurs at the starting of the string, these strings are dropped, right? So these are sometimes quite handy if you want to clean up your text and drop uncertain values or unnecessary values. You can use them. Another very such useful function is make trans, right? So make trans takes 3 arguments, x, y and z. So whatever characters you are seeing in x will be translated to y, right? For example, m will be translated to e, s will be capital S will be translated to capital J, a will be translated to o, and whatever characters that you are seeing in z will be dropped. They will be deleted from the string, right? So let's look at an example string, good night Sam, and you're saying that m, capital S and a should be translated to e, capital J and o respectively, and if you see a character O, D and G, H, T, they should be deleted from the string, right? So you first make a table saying txt dot make trans xyz, and then you can simply call this function called translate on this variable called txt, and you can see that S is translated to J, so Sam becomes Joe, and O, D and G, H, T are dropped, right? So good night, apart from G and I, everything is dropped, so good night Sam becomes G, I, Joe, right? So while this is a toy example, sometimes this is very useful in taking out unnecessary values from your data, right? A simple usage of some simple usage of what we just saw is, let's say if you want to drop punctuations, right? Punctuations sometimes are useful if you are interested in detecting a boundary of a sentence. Yes, punctuations are very useful, but sometimes if you are just counting the number of words you have, in such a use case, you do not really need the punctuations to be present there, right? So in such situations, what you can do is you can just drop them, right? Delete it from your data. And to do that, we'll make use of 2 things here. One is the make trans function that we just saw above, and we'll make use of a set of strings that are already defined in Python string library. So string dot punctuation will give you all the list of punctuations that are there, right? So if you print string dot punctuation, it says that it treats all these are all the elements that are treated as punctuations in Python string. So you can say that if you want just a list of punctuations, you can use this function, but more interestingly, look at this piece of code. So we are saying that going back to the previous example, x and y are translation pairs. X get translated to y, all the characters in x get translated to corresponding characters in y, and z gets dropped, right? So here we do not want to translate anything to any target, but we want to drop all the punctuations, right? So the arguments x and y here are empty, null, and the third argument where we mention what needs to be dropped from a string, that is where we have mentioned string dot punctuation, right? So in essence, what happens here is all the punctuations will be dropped from the sentence. So this is the sentence that you started with, and you can see there are commas and full stops here, but when at the end of it, what we are doing here is we are printing the set of words that you have, right? And you can see that you have only the punctuations do not figure in this set, right? So only tokens are present here. So so using this make trans, you translated, which these 2 lines of code will basically do that. Will drop the punctuations from the sentence. Here you are doing the lower casing. Again here you are doing splitting based on white space, right? What this piece of code is doing, that it is wherever there is a white space in the string, the sentence will be split there. So at start of every word, it is more or less splitting the sentence, right? And by creating a set, we are just counting the unique words in the sentence, right? So this is more or less a nice summary of what we have covered so far, right? Just to recap, initially we looked at how to read files. Initially we looked at how to read JSONs, how to read tabular data using pandas, and you can extract necessary columns, necessary text columns or text fields from these data objects. Next, we looked at some of the string manipulation methods, some basic functionalities that are built in into Python, and yeah, and this cell here is a nice summary of whatever we have, some of the useful functions that you might end up using, like lowercasing, splitting, dropping some punctuations, and stuff like that.